Hello friends, in the last lecture we have seen numerical based on titrimetry. Today we are going to see neutralization titrations. Actually these are the acid base titration where during the course of titration the H plus ion concentration changes and hence you can say the pH changes. Now what do you mean by H plus ion or what do you mean by pH here is, see, there is a relationship between pH and H plus ion concentration. pH is equal to negative log to the base 10 of H plus ion concentration. Now during neutralization reaction, we know that an acid reacts with base to give salt and water, be it any concentration, but we will get the same things. Alright, now depending upon that, the H plus ion concentration changes because H and OH combine together to form water. So during the course of titration, when the H plus ion concentration changes, definitely the pH changes. pH is nothing but negative log to the base 10 of H plus ion concentration. Now suppose from H plus ion concentration if you wish to find, from pH if you wish to find H plus ion concentration, so H plus ion concentration will be equal to anti-log of negative pH. Alright. Now see, during the course of titration, as I am saying you, this H plus ion concentration will change and the pH will change. So this will serve our purpose to study the titration and how will you determine the end point. Now suppose if we have H plus ion concentration as 10 raised to minus 1. Then the pH of the solution will be equal to 1. If we have H plus ion concentration as 10 raised to minus 3, pH will be equal to 3. Now suppose we have OH minus ion concentration as 10 raised to minus 1. So POH we will get as 1 and we know that pH plus POH is equal to 14. So pH will be equal to 14 minus 1, that will pH will be equal to 13. Now also we know that ionic product of water, that is Kw, is given by H plus concentration into OH minus ion concentration. It is nothing but 10 raised to minus 14 at 298 Kelvin. Alright. Now see, for the determination of endpoint, we have a suitable indicator, or we can use even the instrumental method that we will see later on. But see, during the course of titration, either the pH will increase or decrease depending upon whether the titrant is an acid or it is a base. Now suppose it is a base, the pH will increase. If it is an acid, the pH will decrease. Now before moving on to the thing that is where the reaction is complete, let's first see what do you mean by equivalence point, what do you mean by end point, what is titration error once again. Now see, equivalence point is a point where the amount of titrant added is stoichiometrically equivalent to the amount of analyte. That is, the neutralization reaction is completed between the titrant and the titrant. Now this is the equivalence point. Coming to the end point, it is nothing but the experimentally observed completion of reaction. Through visible indicator, when the color changes, we say the end point is reached. So it is the experimentally determined point at which the reaction seems to be completed. Now difference between the two, that is the equivalence point and the end point, is called as the titration error. Now see, one can use a suitable indicator, visible indicator, which shows change in color at the end point, and the change in color at the end point is very abrupt. So we can easily determine the endpoint. Now suppose if a suitable indicator is not available, then we can go for the instrumental method to determine the endpoint. Now we can use potentiometry. To determine the endpoint, and here measured quantity is potential. Change in potential we measure, or you can use conductometry, where we can use change in conductance. So this can even be used, and then from the graph one can find the endpoint. So this was about this, but let's see that all the indicators cannot be used universally. Means the indicators which are used in acid-base titrations are called as acid-base indicators. The indicator which are used in complexometric titration are called as metallochromic indicator or complexometric indicator, or redox indicators are used in the redox titration. Now see, this endpoint will also depend on the nature of the titrant and the titrant used, whether they are strong or weak, depending upon that. So we shall move on to theory of acid-base indicator now. Now see, first of all we should know that the indicators are either weak acid or weak base. So as they are weak acids or weak base, they exist in two forms, that is ionized form and unionized form. So the indicator may show two colors, that is one with the ionized form and other in the unionized form, or like methyl orange which shows two color, that is in a basic medium it shows some different color than in acidic medium, whereas phenolphthalein, if we see, it shows color only in one medium, that is basic medium, it shows pink color. So this is called as phenolphthalein will be called as one color indicator, whereas methyl orange will be called as two color indicator. Now suppose consider an indicator which is a weak acid, say HIN. It dissociates to give you H plus and IN minus. Now see, this IN minus is a base, whereas this is an indicator, and here it is giving an acid. This is a weak acid. So now for equilibrium constant or dissociation constant for it can be given as KIN will be equal to H plus IN into concentration of IN minus IN upon HIN. So suppose from this, if I wish to calculate H plus, what will it be? KIN into HIN upon IN minus. Now suppose I wish to reverse the sign, or I wish to take log, so it will be log of H plus IN will be equal to log of KIN plus log of HIN upon IN minus. Alright. Now suppose I want to change the sign. negative log of H plus will be equal to negative log of KIN plus log of IN upon IN minus upon HIN. Alright, now we know that negative log of H plus is pH. Similarly, negative log of KIN is pKIN plus log of IN minus upon HIN, that is ionized form upon unionized form. Now see, for an indicator to show its color, its concentration ratio should be at least 10 times, or you can say one part of IN or 10 parts of IN and 1 part of HIN, then and only then its color would be visible. So if I say IN upon HIN should be greater than or equal to 10. So pH will be equal to what? pKIN log 10. Log 10 is what? Plus log 10. Log 10 is 1. So pH will be equal to pKIN plus 1. In the similar manner, if I take the reverse one, so it will be pH is equal to pKIN minus 1. So we can say for acid base indicator, pH is equal to pKIN plus or minus 1 for the visible colors, two different colors. So this was about the theory of acid base indicator. Thank you. In the next lecture, we will see how we have different cases for these indicators. Thank you.